Welcome to Web Handling. My name is Dave Roisum. This is a continuation of a mini-series on web machine design reviews. Here, we outline material handling, as we must. For it does no good to make a highly productive web machine, but not be able to move around wound rolls and other materials in and out of the area with similar speeds and reliabilities. Of all materials that move in and around your web machines, wound rolls will generally have the highest weights, rates, and volumes. The first set of parameters we need to know is the range of roll sizes that all elements in the roll handling system must be able to process. One area the web handler must pay close attention to is any restrictions on roll support. Many wound roll products cannot be supported by either the core or the outside or the end because the roller web can get damaged. We discuss roll support in great detail in our 2-day winding class. The next roll handling parameter needed is the rate of production of both master rolls and daughter rolls. Note that the rates that the system must have must be somewhat greater than the base web machine's productivity. As we covered in the industrial engineering module of our web winding class, we never want to block or starve our main web machine. Starving might, for example, mean that we do not currently have an input roll to run on our laminator because maybe the forklift truck driver was on break. Blocking might, for example, mean that the output going to the roll wrapper is bottlenecked because we only have one and it is currently down for repairs. Master rolls are the easier of the two areas. We must be able to handle the worst case combination of maximum web machine speed and minimum roll length. Some base web machines slow to run heavy products, in which case some compensation may help the thus shorter lengths in the master roll. Rewinders do not have that luxury. Indeed, rewinder productivity is far more complicated. We taught an entire module, Web20150e, on that very subject. Even more detailed analysis was given in my first winding book, as well as a few articles you can find in the Roisum library using the search term time cycle. Fortunately, the Winder Productivity Calculator by Abbott App can do much of the heavy lifting of calculations for you, once you understand the requisite background. There are so many ways to automate roll handling, either at the winder or elsewhere, that we simply cannot even list them here. Indeed, there's no need, as we cover most of the common options in Module Web20150e of our 2-day winding class. However, I want to merely highlight a couple of very serious considerations with regard to automation. The first is reliability. If you have an operator get sick on a totally manual system, he or she could be replaced in minutes. However, if you have a crane or a robot get sick, your entire production could be down for hours or days. Unfortunately, complex machinery has many more failure modes. Also, custom automation has a much higher failure rate than, say, robots that have been tested and field proven with hundreds, if not thousands, of nearly identical models before you order yours. The second area is safety. Automation makes sudden and unexpected movements. Light curtains, if not complete fencing of the area, is needed because, as they say, robots can have a very nasty backhand. This need for the highest levels of safety unfortunately make fallbacks and maintenance even more challenging. Thus again returning to our need for higher levels of reliability than perhaps any other part of the plant. We covered MTBS, mean time between service, in the performance agreement section of our web machine buying guidebook. Once we have our roll handling system sketched out, we next need to move on to other materials that are needed in the area. In addition to listing those materials and their rates, we also need to begin to take a close look at supply paths and interim storage. Traffic engineers do such things when studying streets and intersections. Where are the cars stored, and for how long behind stoplights and the like? How can we avoid conflicts and paths that intersect? How big do paths need to be to handle a car with trailer, or semi-tractor trailer? Identical studies should be done in your plant's layout, both near and far from the web machine. Last but not least, we need to consider our people. This would include operators and all of their common duties and all of their common paths. This would include routine maintenance. Just one of many examples here is to collect grease points into a common manifold so that lubrication is made faster and more reliable. Then there are the less routine maintenance that is still nonetheless required. One is common enough that we need to expect it to be handled as a science. That is the need to be able to change out process rollers quickly and reliably. Another no less important area is to consider forklift transit. If a forklift is ever used for parts, you must allow access to an aisleway transit, if not also a generous turn radius. Mere transit might require as little as 1 meter, but a generous turn radius could require a 3 or more meter wide aisleway. All of these studies are the realm of industrial engineering. Only those who are formally trained or highly experienced could be expected to do well in these specialized areas. Thank you so very much for watching this module in my Plant Practical video series. This concludes, for now, our primer on web machine design reviews. Stay tuned for even more web machine topics.